Hello everybody, welcome to the live science stage here at Pacific Science Center. My name is Marissa and I will be doing the Physics of Bubbles show with you all. Helping me out today is my friend Max. Max, come say hello.
Hello.
All right, physics of bubbles. Now, sometimes people think that physics sounds intimidating or confusing, but physics is really just the study of how stuff works. So, the physics of bubbles is how bubbles work. Let's find out how bubbles work. The first thing we need to figure out is the ingredients in bubbles. I have one of those ingredients in these cups right here. Now, right now, these cups are full of water. But you can make bubbles in liquids other than water. Think about soda. Maybe you've seen bubbles in soda. Maybe you've blown bubbles in chocolate milk before. The first ingredient you need is a liquid, any kind of liquid. To figure out the second ingredient, Max is going to come help me out. Come on up here, Max. All right, Max, I'm going to give you one of these cups.
Okay.
And in just a moment here, I need you to pretend that we are in the nicest, fanciest 4-star restaurant in town. And we're going to do what anybody would do in that situation. We're going to blow a whole bunch of bubbles. So, ready, get set, go! And stop! Who blew more bubbles?
It looks like I did.
It looks like you did. Do you think there was something in your cup that wasn't in my cup?
I think so. It
What?
looks all soapy.
It looks soapy, that's right. The second ingredient is soap. Thank you so much, Max. You can dry yourself off with this. Now, soap is an important ingredient because it reduces surface tension. To talk about surface tension, I have this nifty sign right here. This is a picture of a cup of water. Inside of this cup, you can see all these different circles. These circles represent water molecules. You may have heard the word molecule before. Everything in the whole world is made out of molecules. I'm made of molecules, you're made of molecules, and so is water. But water molecules are kind of special. Water molecules are really sticky. They like to grab on and stick to other water molecules. So if we look at the one in the middle here, all those pink arrows coming off of it tells us that it can move around and grab on to other molecules in all different directions. But check out these ones on top. They only have arrows going downwards. They can only grab onto molecules next to them and the ones underneath them. That creates a little skin on the surface of the water that we call surface tension. So when you blow bubbles in a normal cup of water, those bubbles float up, they bump into that skin, and the side-to-side pulling and downwards pulling rips those bubbles apart. That's why you need something like soap, which breaks that up and lets bubbles pass on through, just like in Max's cup. Now, if you put together soap and water and a little bit of something called glycerin, you get a very special scientific substance. We call that substance bubble goop. Bubble goop. Now, bubble goop is special because it is elastic. You may have heard of elastic things before, things like a rubber band or the waistband of your underwear. If I took my underwear and I stretched it out as far as it goes and then I let go, what would happen? It would snap back because elastic things want to be as small as possible. It's the same with bubble goop. I will show you. Now I'm holding up this bubble wand right here. Can you see the string down the middle of it? Can you see the bubble goop in each window on each side? Watch what that string does when I pop one side of bubble goop. It's snapped over to the side. The bubble goop in this window is trying to be as small as possible. Now watch what happens if I try to bring that string back into the middle. It snaps back, just like a rubber band. So on the outside of a bubble, we have this elastic liquid, this bubble goop. On the inside of a bubble, we have something different. We have air or a gas. And that brings us to the very definition of a bubble. A bubble is a gas surrounded by a liquid. A gas surrounded by a liquid. And that liquid on the outside is trying to make itself as small as possible, but the gas on the inside is trying to escape. It's pushing out as hard as possible. That gives us a very specific shape. Folks, What shape is a bubble? In this picture right here, it is a round shape, what we would call a sphere. But I'm going to see if I can make bubbles in shapes different from spheres. I have a few different special bubble wands with me here today, and I'm going to do some experiments with them. The first bubble wand I have is a square shape. Let's see if I can make a cube-shaped bubble with my square bubble wand. Here we go. And cube, cube, cube. That is not a cube, that is a sphere. Let's try something else. I have a triangle bubble wand. Let's see if I can make a pyramid-shaped bubble with my triangle wand. Here we go, and it popped. Let's try that again. And pyramid, pyramid, pyramid. That is not a pyramid. That is a sphere. All right, I have something else to try. One last bubble wand here. I have my giant bubble wand. Let's see what shape I can get with my giant bubble wand. Here we go. And whoa! It turned into a big, long, wait a second though. It started out like a big, long tube bubble, but then it started to turn into a sphere. Let's try that one more time. That was pretty neat. I'm going to make a big, long tube bubble. Whoa! And it's turning into a sphere again. Bubbles are always going to turn into spheres. There is a way to make a bubble that isn't quite a sphere, though. To do that, I need a very special prop here. I need my plastic board. I'm going to take some bubble goop and I'm going to spread it onto my plastic board, like so. There we go. I'm going to make one bubble. Bloop, and I'm going to catch it. Ha! Just like that. Now this is not quite a sphere. This is more of a dome, hemisphere type shape, half a sphere. Now the reason this is happening is because right now my bubble is sharing a wall with my plastic board. And that brings us to another part of the physics of bubbles. Bubbles are lazy. If they can share a wall with something else, they will. Now, while I have this bubble here, there's an experiment I want to try. I brought something else with me here today. I brought this. Now, to the untrained eye, this might look like a knife, but this is not a knife. This is, in fact, a sophisticated bubble popping tool. Let's see what happens if I bring my sophisticated bubble popping tool to my bubble. It popped! I'm going to do that again. I'm going to make another bubble. I'm going to catch it. I'm going to make a bubble. I'm going to catch it. Aha. And with my bubble popping tool. What is going on here? Is it broken? Oh, you know what I did? I dropped my bubble popping tool into my bubble goop. It's all wet now. So now these bubbles are sharing a wall with my bubble popping tool. Now this tells us something very interesting. It tells us that it isn't sharpness that pops bubbles. Otherwise, that would work. It is in fact dryness that pops bubbles. Also force. Force also pops bubbles. All right, my friends, we have seen big bubbles and little bubbles and dome bubbles, but now it is time for the exciting bubbles. Let's see some exciting bubbles. Now, some of these exciting bubbles will be filled with stuff that's kind of dangerous. So before I get started with all of that, let's take the Pacific Science Center safety oath. Go ahead and raise your favorite hand into the air and repeat after me. I promise. When I'm around dangerous things, I will always be safe. Fantastic. All right, let's get started. So earlier I said the definition of a bubble is a gas surrounded by a liquid. So far we've been using the same gas for all of the bubbles, just regular old air. But I have some different gases with me here to try out. One of those gases is in this balloon right here, and I'm not going to tell you what it is. We're going to start by making some observations. I am going to attach this balloon to this tool right here. We call this a bubble horn. I'm going to attach it right onto the end, and I'm going to dip it into my bubble goop. And let's see what these bubbles do. Let's make some observations. Here we go. Look at those bubbles. They're going up. They're floating. Now this is a gas that is lighter than air. You might already have a guess about what it is. It is in fact helium gas. Helium is a gas that is lighter than air, so it makes bubbles that float. I also have a gas that's a little bit heavier than air. Now this is one of those dangerous gases I was talking about, although right now it is not in the form of a gas. Right now it is a liquid. We call it liquid nitrogen. And liquid nitrogen is dangerous because it is very, very cold, about negative 320 degrees Fahrenheit or negative 196 degrees Celsius. So cold, I need goggles and gloves to protect me. And so cold that it boils at air temperature. Right now, this stuff is boiling away in this cooler. And as it boils, it turns into something. Folks, if you think about a stove at home, a pot of water on a stove at home, how it's boiling away, it's turning into steam, it's turning into a gas. Liquid nitrogen does the same thing. As it boils, it turns into nitrogen gas. So let's see what happens if we fill bubbles with nitrogen gas. I'm going to put on my safety gloves. I'm going to take 1 scoop of liquid nitrogen. And in a 3, 2, 1 countdown, I'm going to pour it into this container of bubble goop. Here we go. 3, 2, 1. Whoa! Look at that! It's erupting. It's a bubble-cano! And a really big mess. Now, here is the other cool thing about liquid nitrogen. When something turns from a liquid to a gas, it expands. It takes up more space. So 1 cup of liquid nitrogen turns into more than 700 cups of nitrogen gas. That is a lot of gas, and that makes a lot of bubbles. Now, it's safe for me to stick my arm in here. Let's take a look at what's inside of this container. Right now I'm holding some bubbles, but those bubbles aren't trapped in liquid. They're trapped in ice. Earlier I said the definition of a bubble is a gas surrounded by a liquid. It can also be a gas surrounded by a solid. All right, fantastic. Now folks, we have seen floating bubbles, we've seen frozen bubbles, but now it is time for the best bubbles of all, the grand finale bubbles. My friend Max is going to come up here and help me out. Come on up, Max. We are going to fill bubbles with hydrogen gas. Hydrogen is flammable. That means it catches on fire. So my friends, we are going to make bubbles that light on fire. I'm going to run in the back and turn down the lights. All right, here we go. Whoa! Whoa, that was a loud one. Just a few bubbles left. Here's one. Oh, here's another. And I think this is the last bubble. Here we go. Oh no, it got away! Thank you all so much for watching the Physics of Bubbles show. Have a great rest of your day. If you have any questions or comments, feel free to comment on the video. Thank you again. Have a good one.